All righty, friends. How you doing? How you doing? So you guys have finished off the algebra portion of the class. Now we're going to go jump into the trigonometry portion. So the second quarter, we're going to be looking at trig. Now, you guys did trig back in integrated 2 and a little bit integrated 3, and you dealt mostly with it being triangles. So we're going to stick with triangles for a couple days, but eventually we're going to allow triangles to branch us off into what trig really is, and that's dealing with circles. So now you guys know, well, this kind of printed up a little weird, didn't it? You guys know majority are the three main trig functions. So you guys hopefully have learned that sine is the opposite over hypotenuse, that cosine is adjacent over hypotenuse, and that tangent is opposite over adjacent. And again, we have these abbreviations. So when we see sin, that doesn't necessarily mean sin. It means sine. I don't know why they dropped the E. All the rest of them are 3, so that's why they did it, but still weird. COS is cos, but we say that represents cosine. The abbreviation tan is tangent. Now, these are the three trig functions that are on your calculator, and we've dealt with them before. But we're going to add a few others. We're going to have something called CSC, and that means cosecant. We're going to have SEC, and that stands for secant. And we're going to have COT, and that stands for cotangent. So if you're looking at these trig functions here, we know that sine, again, we have it already. Sine is opposite over hypotenuse. But we call it the reciprocal function. It's reciprocal. The one that it's paired with is cosecant. So CSC, this is the reciprocal of sine. So instead of being opposite over hypotenuse, this would be hypotenuse over opposite. Also, this isn't sine to the -1. That's inverse sine. That's how we find the angle. This is just a reciprocal function. So we have cosine of theta. And cosine of theta is adjacent over hypotenuse. And it also has one of these reciprocal functions, and that would be secant. So SEC, that would be hypotenuse over adjacent. So we just take the values and we're just flipping them upside down. And then tangent of theta, that is opposite over adjacent. And its reciprocal function is cotangent. That one actually makes sense. Tangent and cotangent. Seems like they should go together. So COT. And that would be adjacent over hypotenuse. And again, you have these kind of written here in your notes. But just remember, these are called the reciprocal relationships, the reciprocal functions. The reciprocals of each other. Sine is the reciprocal of cosecant and vice versa. Cosine is the reciprocal of secant and vice versa. Tangent is the reciprocal of cotangent and vice versa. So from there, back in integrated 2, we learned something called complementary angles. And with complementary angles, we learned that some of them are our complementary angles are angles that add up to 90. Well, we have angles that are complementary towards each other. We say that they are complementary cofunctions. In other words, sine and cosine. Notice the first two letters of complementary is co. So if I take sine and I add the two complementary letters, cosine, we'd find out that sine is complementary to cosine. That means sine theta equals cosine of 90 minus theta. But realize that's also the same thing. Cosine of theta is going to be equal to the complement of sine. So it's not just one way, it goes both ways. And what that means then is sine of 32 is going to be equal to cosine of 90 minus 32, or cosine of 58. Now that's in degrees. There's two different ways to type this in your calculator, and I'd like you to go ahead and type it into your calculator so we start to remember how to do that. So when we go to type it into our calculator, the first thing you need to do here is you need to go to your mode button, because we have to make sure that we are in the correct mode. And you only got to do this the first time you use it. So you're going to see a couple levels ahead of it. But the third level, you're going to see something that says radians and degrees. Most likely, the word radians is highlighted. So what you need to do here, friends, real quickly is you need to go and highlight degrees and press enter on it. We need everything in terms of degrees. So type in sine 32 into your calculator and press enter, and then type in cosine of 58 in your calculator and press enter, and you'll notice they're the same values. So we have our reciprocal functions and we also have our complements. Secant is the complement of cosecant. So a way to think of that one here is you have secant, and if you add those CO in front of it, the complementary letters, you get cosecant, which is why they are complementary of each other. So if secant theta equals cosecant 90 minus theta, that means cosecant of theta, I'm going to run out of room here on this one here, cosecant of theta would be the same thing. Cosecant is secant of 90 minus theta. Because they're complements of each other. And tangent and cotangent would do the same thing. They're also going to be complements of each other. So we have these reciprocal relationships. We have these complementary relationships. So what we're going to do is we're just going to kind of play with them a little bit here. Find the exact value of the 6 trig functions. So first thing we always want to do is we want to label our sides of opposite, adjacent, and hypotenuse. So now, real quick, there is a box missing here. Let's add that right angle in there. And if you notice, friends, I have the opposite side. I have the adjacent side. What I don't have is the hypotenuse side. So in order for us to find that, that's that C value, we're going to go back to an oldie but a goodie. We're going to go back to the Pythagorean theorem. So a squared plus b squared equals c squared. So if we're going to plug everything in here, so we have 8 squared plus 15 squared. And by the way, it doesn't matter, 8, 15, doesn't matter which one's A, which one's B. All that matters is that the hypotenuse is C. So we have 64 plus 225 equals C squared. So 289 equals C squared. And we're going to go ahead and just take the square root of both sides, and we end up with 17 equals C. Now, there's some of you out there that are probably going to say, wait a second. When we take a square root, it's supposed to be plus or minus. And usually, And I would say, yeah, you're right in algebra. However, unless I'm dealing with an XY axis, or unless I'm dealing with algebra, kind of an algebraic equation that I'm solving, if it's something that's geometric in nature, we don't deal with negative values. So we can go ahead and say that this is just going to be the positive value. So we don't have to put plus or minus at this point in time. We will in a few days, but not yet. Well, next week, actually. So now we have our sides. So now we can go ahead and deal with everything here. So sine of theta. Remember, that's going to be opposite over hypotenuse. So sine of theta then is going to be 8 over 17. Cosine of theta, that would be adjacent over hypotenuse. So that would be 15 over 17. And then we have tangent of theta. Well, that's opposite over adjacent. So opposite over adjacent would be 8 over 15. And so that takes care of our normal 3. Now we do the reciprocal functions. So cosecant of theta. And guys, I won't write opposite and hypotenuse and all that kind of stuff over and over again. I'm just doing it here at the beginning just so we can get the idea of what these are. So cosecant is hypotenuse over opposite, so that's 17 over 8. Secant of theta, that's the reciprocal of cosine. Secant of theta is hypotenuse over adjacent. So that would be 17 over 15. And then our last one, cotangent of theta. That's adjacent over opposite. So that would be 15 over 8. Alrighty, so we get an idea here of kind of looking at how all these things kind of play out a little bit. So what I'd like for you guys to do here, if you guys don't mind, and whether you do or you don't, doesn't really matter. I'm going to give you guys one to try yourselves here. So we'll make that 4, we'll make this 3, and we'll make this theta. Ladies and gentlemen, I want you guys to go ahead and pause the video and go ahead and figure out all 6 trig functions through this expression. All right, so let's see what you guys have here. First of all, we have the hypotenuse. We have the opposite. What we don't have is the adjacent. So that's what we're looking for. We're looking for that adjacent side. So a squared plus 3 squared equals 4 squared. So 8 squared plus 9 equals 16. A squared equals 7. And a equals the square root of 7. Now, friends, it's perfectly okay for us to have radicals. All right. Now, unless it's on the unit circle, which we're not going to deal with right now, we don't have to rationalize our denominators. We can leave them alone here. Okay. So we're going to go back through here and we'll do it all over again. So sine of theta, that is opposite over hypotenuse. So that would be 3 over 4. If I know that's what sine is, and that means I also know then what cosecant is. It's just the reciprocal of that, hypotenuse over opposite, 4/3. Cosine, that's adjacent over hypotenuse, root 7 over 4. So secant of theta. Now notice, I end up with my radical in the denominator. That's okay. It really is, friends. I know that back in algebra 2, you're asked, to simplify your radical, and so you did that by multiplying or an integrated 3, depending on what class you came from. So you multiply the top and the bottom by root 7 over root 7. And you end up with something like 4 root 7 over 7. Friends, that's, and then you're told that that's simplified. No, it's rationalized. It's not simplified. You can do that if you want to. You don't have to. All right. In calculus next year, you're allowed to keep radicals in the denominator. So go ahead and leave the root 7 in the denominator. Again, unless it's a unit circle angle, which we don't know what that is yet, you can leave radicals alone. You don't have to simplify. And then last and certainly not least, tangent of theta. That is 3 over root 7. Totally good with that answer. And cotangent of theta, which would be root 7 over 3. And again, I know there's somebody in the class that's going to say, wait a second, I'm just not okay. That's fine. Go ahead and you can go ahead and do your multiply top and bottom by a radical if you want to. Just realize you don't have to. Okay, leave it alone. All right, so let's keep going here a little bit. Whoop. So now we're going to try a couple more here. You're given some information. So we'll do a couple. I'll do the first one, then I'm going to have you guys pause and do the second one here. And it's essentially the same kind of thing we did before. It's just now we have to figure out where the sides go. So sine is opposite over hypotenuse. So that means 5 is my opposite side, 6 is my hypotenuse. So I'm going to go ahead and write them up. And I got to figure out what the A value is. There's my opposite. Here's my hypotenuse. And I'm looking for the adjacent side. So A squared plus 5 squared equals 6 squared. And again, this isn't going to be too terribly bad. A squared plus 25 equals 36. A squared equals 11. So A is the square root of 11. So now we're ready to go ahead and figure out what all the trig values are. Sine theta, opposite over hypotenuse, which means then that cosecant of theta, one of these new ones we learned, is the reciprocal of that. So that would be 6 over 5. And so your cosine of theta, that would be root 11 over 6. And secant of theta is 6 over square root of 11. And tangent of theta, that would be 5 over root 11. So that means cotangent of theta is going to be the reciprocal of that. So root 11 over 5. All right, friends, why don't you guys pause the video and see if you can't try this next one here. Well, the first thing I would do here, I got a single number. We deal with fractions here, friends. So that means secant, that's the same thing as hypotenuse over adjacent. So hypotenuse is 3, adjacent is 1. And we got to go and figure out what the A value or the B value is on this one here. I mean, I can call it 8. Again, it doesn't matter. So in this case, I don't know what the opposite side is. That's an A, by the way. So 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. So b squared is 8. And friends, that means b is the square root of 8. Now again, I know that there's going to be somebody out there that says, can't leave it like that, man. It needs to be 2 root 2. And you know what? You do you. If you want to do that, you do that. Because as a math guy, I'll be honest, 2 root 2 doesn't tell me a whole heck of a lot. All I know about 2 root 2 is it's going to be between 1 root 2 and 3 root 2. That doesn't do a lot for me. Math folks, for the most part, we prefer to have them left alone. So root 8, that tells me a little bit. I know root 8 is between root 4 and root 9. So I know a little bit more about root 8 than I do about 2 root 2. I know it's going to be somewhere between 2 and 3. And since it's root 8 is closer to root 9 than root 4, it's going to be closer to 3. It'd be about 2.83, 2.85, somewhere around there. So go ahead and leave that radical alone as root 8. You don't have to do 2 root 2. All right. I know some of you guys, you're going to do it. You've been so programmed. All right. And that's okay. If you do it, I'll still give it to you. Just, I mean, obviously it's not wrong. It's right. It's very right. But make sure you do it correctly. I'm going to leave it though as root 8. So opposite over hypotenuse, that's root 8 over 3. Cosecant of theta, that would be 3 over root 8. And again, next year, guys, on the AP Calc test, you guys don't have to simplify square roots anyways. So if this is pre-calculus, we should be preparing you guys for calculus. So go ahead and leave that as root 8. And also don't worry about rationalizing the denominator. The only time you have to do that stuff, friends, is when you are taking a standardized test or when it's on the unit circle. So adjacent, that's going to be 1/3. And we already knew that secant was 3 over 1. Because that's one we were given. And tangent of theta, that's going to be root 8 over 1, which is root 8. And cotangent of theta, that would be 1 over root 8. All right, so hopefully you guys kind of have the gist of this idea of how this stuff kind of plays out here. Let's do one more little triangle problem here. I want you guys to go ahead and take a turn here. Do me a favor, though. There's no reason for this to be tangent here. Let's make this one. Oh, we'll make this one tangent of 90 minus theta. We'll do that instead. That'll be more fun. All right, go ahead and pause the video and see what you guys come up with. All righty, so first things first, we have a right triangle that we got to draw. Oh, that's a big right angle. And we also got to label our sides. Tangent is the same thing as opposite over adjacent. So that makes that 3 over 4. That's not the color I want. Yellow just doesn't show up real well. Opposite and adjacent. And friends, on this one, we're missing the C value. And this is one I'm sure you guys could probably do on your own head. This is the most familiar of every right triangle. 3 squared plus 4 squared equals 5 squared. All right, so cosine. That'd be adjacent over hypotenuse, so that's 4 over 5. Now notice, tangent of 90 minus theta, so that's a 90, 9d. I'm not going to worry about trying to figure out what tangent of 90 minus theta. What I'm going to do, though, is I'm going to turn it into its complementary function. So if I have tangent 90 minus theta, its complement is cotangent. So tangent of 90 minus theta is the same thing as cotangent of theta. And that I can do. If tangent is 3 over 4, cotangent is 4 over 3. Cosecant is hypotenuse over opposite, so that's 5/3. And same thing here, cosine of 90 minus theta, well, I'm going to use its complement again. So 90, or I'm going to change that to sine of theta, which I know is 3/5. All right, so we're cruising through here pretty good. Kind of getting the gist of how this right triangle stuff is. We're kind of working a little bit. Now, friends, you can kind of see it a little bit better on my picture than you can on your notes probably. Angle of elevation, you always start from a horizontal line and you go up. So angle of elevation is the horizontal line up to the sight line. This is called the line of sight. All right, so that's where you're going to sight that balloon, potentially, or wherever that might be. Angle of depression starts with the upper one and it goes down. And if you notice here, these angles make the letter Z. Those are back in integrated 2 or geometry, depending on what you came from. We call those alternate interior angles. But we'll use parallel lines relationships a lot. So we use this alternate interior angles a lot. And that's not the only one we're going to use. So we're going to use corresponding angles and vertical angles as well. So let's see here. Let's take a look at alternate interior angles. Angles C and F. Well, these are angles that form the letter Z. Realize these aren't the only angles that form the letter Z. D and E would also have been alternate interior angles as well. So I always remember alternate interior angles as angles that form the letter Z, but again, you guys are pros. I'm sure you remember a lot of this stuff. A and E, these are corresponding angles. I always remember corresponding angles because they form like angles inside of a slanted F. So where's A and E at? Here's A. There's E right there. You can kind of see that slanted F there. So those would be angles A and E. Notice, again, those aren't the only angles that are corresponding. Angle C is corresponding to G, they'd be congruent. H is corresponding to D, they'd be congruent. F is corresponding to B, so they would also be congruent. So we have a whole bunch of corresponding angles here. But we're just looking at a few of them here. And then vertical angles, and again, you guys are pros at this stuff. You've done all this stuff before. You guys remember all this. A and D, those are angles that form X. So anytime you have angles on the opposite side of the letter X, you can see the angles A and D on the opposite side. Those would be vertical. Notice B and C would also be vertical. They'd be congruent as well. So again, all these things you guys dealt with back in integrated 2 or geometry, depending on where you all came from. So not terribly worried about it. I know you guys will be pros with this stuff. But let's take a look at what we got here. A biologist wants to measure the width. Okay, you can see that W right here. That's not going to show up. Let's use black. That width for W of a river to properly set instruments for studying the pollutants in the water. From point A directly across from point C, so they're right across from each other. So that means that's going to be a right angle. The biologist walks to B. So from A, they walked that way to B. And sets the sights on point C and determined it was a 58-degree angle. How wide is the river? So if you notice here, friends, holy jumping catfish, that's got to be the worst right triangle in the world. So if we're looking at this stuff, here's what we really have going on here. And you can see it drawn on the picture there. W, 100 feet, and 58 degrees. So all they're asking us to do is figure out the width of that rectangle. So friends, go ahead and pause the video and solve it real quick, and then I'll come back and see you. All right, let's see. We have opposite right there. We have the adjacent over here, right, like that. And we're going to solve the dumb thing. So sine of 58 degrees equals opposite over adjacent. And again, if it helps you, you can go ahead and put it over 1. Doesn't matter. But we're just going to cross multiply it here. So W is 100 times sine of 58 degrees. Plug that into your calculator. Why don't you guys go ahead and plug that into your calculator and press enter. All right, and we got 160. Now, for our purposes here, there's different things you can do here. Now, sometimes you deal with things called significant figures or significant digits. We're not going to do that. At the same time, a lot of teachers will say round to 2 decimals or 3 decimals. The College Board, when you take AP Calculus, always wants you to round to 3 decimals. However, if you go to 4 decimals, whether you round it or truncate it correctly doesn't matter. If you go to 4 decimals, you're always right. So they won't dock you even if you round wrong or don't round at correctly to the 4th decimal. If you just put the 4 decimals out there, they'll give you credit. So for pre-cal, we always go to 4 decimals so we don't mess that up. So we ended up with 160.0333 feet. So what I'm going to do, friends, I'm going to give you a problem. Let's say you have some sort of a tree. I don't care what the tree is. All right, I'm not going to bother drawing it out there. I am going to just kind of let you see it here, though. We'll call this a tree. It looks like a tree. It's a good-looking tree. Now that tree is standing on flat ground. And it's a big tree. You can see it from really far away. Now, a person is standing over here and they're looking at the tree. Oh, hello there. All right. And they look at the tree and they notice from when they notice from that height to the angle of elevation, so say like they're using a clinometer or something like that to be able to measure that angle of elevation, they noticed that it was 5 degrees to the top of the tree. So what they did, this person, and let's let this person be 6 feet tall. I almost made 6 feet. 5'11", I was close. So let's let this person come 100 feet closer. And this time when they came 100 feet closer, this time when they spotted it, the height, they noticed that it was 8 degrees. What I'd like for you guys to do, if you don't mind, whether you do mind or not, doesn't matter, friends. I'd like you to figure out what is the height of the tree. Using right triangles, see if you can go and figure it out. All right, let's see how y'all did. Now, first of all, notice I'm not calling this height of the tree. I called that y instead of h because you got to remember, the person is 6 feet off the ground when they have their angle of elevation. So whenever my answer is for y, I'm going to add 6 to it. I don't know what this length is right here, so I'm going to call that y. And so when I'm looking at this, I see 2 triangles. I see one triangle that is 5 degrees, y, on one side, and on the base, it's 100 plus whatever that x value is. On the other tree, when we walked in 100 feet closer, I noticed that that angle is 8 degrees, still y, and it's still x. Well, friends, both these triangles are dealing with the opposite and the adjacent sides. So what we got to do is we got to go through and figure out the whole thing. So let's use tangent here, since that's what opposite and adjacent is. So the tangent of 5 degrees equals opposite over adjacent. On this one, I have tangent of 8 degrees is opposite over adjacent. I see they both have a single y, so if I were to cross multiply these here like that, I could get y by itself. So y is 100 plus x tangent of 5 degrees. Y equals x times tangent of 8 degrees. So friends, these are going to be the two things that we are going to set equal to each other. Not y, we're doing y. So that means 100 plus x tangent of 5 equals x times the tangent of 8. Okay, so if you had trouble getting to this part, why don't you go ahead and pause it from here then and go ahead and see if you can't finish it from there. All right, let's see how you did. Like, essentially from here, friends, it's just an algebra problem. We have tangent of 5. So as you guys can tell, I'm just not keeping it in parentheses anymore around the angle. If I just have a number right beside it, I know that that means angle. And x tangent of 8. So I know I got two different x's, so I'm going to move all the x's to one side. Could have done a bad dad joke there, but let's just keep going here. So we have x tangent of 8 minus x tangent of 5. And we're going to factor out the 8 here, or the x there, sorry about that. Because we don't want to have two x's, we really only want to have one x. So to get x by itself, so tangent of 8 minus tangent of 5. And since that whole thing is multiplied by x, if I divide by it, I get x by itself. So 100 tangent of 5 all over tangent of 8 minus tangent of 5. And friends, that would be equal to x. So now go ahead and use your calculator and see if you can figure out what that value is for x. Remember, this is just an approximate value. So when I plug in that whole thing, I get 164.910. Now we don't round, so I have to take all of these decimals with me, 9106183. So being that I don't want to keep typing that number all over again, what I want you guys to do is I want you to hit the store button on your calculator. You'll see that in the bottom right-hand corner, store with an arrow. And you're going to be able to store it as any letter you want. I really recommend you don't use X. So you're going to hit your alpha button, store alpha, and then pick a letter. Doesn't matter what letter you use. The letter will always be up here in the top left-hand corner, and it'll be written in green. So pick a letter you want to use. It doesn't matter. So for me, I'm going to use the letter A here. So I'm going to store it as the letter A. So 164.9106183. So when I'm going to do this, I'm going to store it as the letter A. Now, you don't really have to do that on this one because we aren't necessarily going to be dealing with multiple letters. And after you do that, make sure you press enter. It'll just type the number again for you. But now if you don't want to type that number over and over again, you just type alpha A. But that is going to come up a lot later on. We'll talk about it in class a little bit, where we're going to have to use big ugly decimals to help us out. So by doing that, now I know that that value is the value A. So, and I would just use A anytime I needed to use 164.9106183. But since I'm only going to use it for one time, I don't mind actually writing it out once. So I know what X is. I got to go and figure out what Y is because that's going to be majority of the tree. So there's my X value. Notice I'm not rounding, I'm leaving it all the way out. I'm going to multiply by tangent of 8. If you stored it as a letter, go ahead and use that letter. So when I did it, I actually did A times tangent of 8. So I actually did use the A on my calculator. And I end up with 23.1767. So since this is going to be my final answer, I can go ahead and round to 4 decimals. But realize that's not the height. I have to add 6 to it because my original guy was 6 feet off the ground. So I have that extra 6 there. So the actual height is going to be 29.1767 feet. That's a pretty good sized tree right there, friends. So, all right. That's enough for one night. Why don't you guys go ahead and you're going to get this video uploaded here in about 20 minutes, so you guys can actually do that this evening here. And I will see you guys in the morning. All right, take care.